Good morning. I am Dr. H. Nandhu Kishore, serving as Assistant Professor in the Department of Computer Science and Engineering. So today we are going to discuss about the topic software process model. So it comes under the area software engineering. So before going on to the software process model, we must know what is software engineering. So software engineering, so before on that we will be seeing the outline. So in this outline we are going to discuss about the introduction to software process model. So classification of software process models, perspective process models, and we will be summarizing all the models. So software engineering is the application of systematic, disciplined, quantifiable approach to the design, development, operation and maintenance of software, as well as we will be studying these approaches. So it is systematic because we will be following the process model step by step, and it's a disciplined approach because we will be developing the product in a quality manner, and we have to design, develop, operate and maintain the software, and we are going to learn these approaches. So introduction to software process models. So a software process model is an abstract representation of a software process. So in every software organization, it is going to define a unique set of framework activities. So for every framework activity, a set of software engineering action will be well defined. So for every action, there will be a series of tasks will be carried out, and finally we will be applying the resultant process model in order to come out with a quality product. So need for the software process models. So the necessity for software process model is to overcome the difficulties and inadequacies such as exceeding scheduled time and cost. The user satisfaction will not be met if we are not following the software process model, and it may lead to a poor quality. So in order to overcome these limitations, we are following the software process model, as well as it reduces the risk by improving the visibility, as well as it allows the project changes to be carried out as the project development has been started based upon the feedback from the customer. So next is the framework activities of software process models. So we are every software engineer, they have defined 5 key process activities, that is as a framework activity. A generic process framework encompasses the following key process activities such as communication, planning, modeling, construction and deployment. In the first phase is the communication. In the communication, we will be gathering the requirements for the software development, and in the planning phase, we will be prioritizing the requirement, and we are going to plan the budget, cost, as well as schedule for the project, and then we will be moving on to the modeling phase. So in this modeling, we will be doing the business modeling as well as the software design modeling, and then we will be starting the implementation of the software design, and finally we will be delivering the product to the client in the deployment stage. So these are the 5 important key framework activities that are carried out in the software development models. So next is the classification of software process models. So we are having various process models. The first major process model is the perspective process model. So it includes conventional models, incremental process models, evolutionary process models, specialized process models and agile process model. In perspective process model, we will be having the conventional model. This is the first and foremost developed model, and then we have incremental process model. In this incremental process model, we have 2 types. One is the incremental model, another one is the rapid application development model, what we shortly called as a RAD model. And then we have evolutionary process models. In evolutionary process model, the project is developed time by time, which includes the prototyping model, and then we are having spiral model and a win-win spiral model, and third one is a concurrent development model. And apart from this perspective process model, we have specialized process models available. In this specialized process model, we have component based development model, which is called as a CBD model, and then we have formal methods model, which is nothing but the mathematical model. So this is mainly useful in research and development activities, and then we have aspect oriented software development model. And then finally we have agile process model. So in order to overcome the difficulties in the previous models, we are using the agile process model in order to come out with a quality product as well as to develop the project within the right time and the right budget. So here we are following the extreme programming process, what we call as the XP process. So in this XP process, we'll be doing XP planning, XP design, XP construction, XP implementation, and then finally delivering the product. So today we'll be mainly focusing on the perspective process model. So in this perspective process model, we have a conventional process model available. In the conventional process model is the first process model that is present in the software development. So it is also called as the waterfall model or classical life cycle model. So it is the first published model in the software development process. So we are going to discuss about the waterfall model. So it is named as waterfall because, so how we drop a cloth in the top of the waterfall, it completely reaches to the bottom of the waterfall. Similarly here in this software development process, so we will be carrying out communication, and then we will be moving on to planning, and then modeling, then construction, and finally we reach to deployment. Since it moves from communication process to deployment process in a linear sequential manner, we call this model as a waterfall model. So this is the conventional software process model. It's a primitive process model that is applied in the software development industry. So it is followed only when all the requirements of the software development are well understood and they are well defined. When the work flows from communication and it reaches to the deployment in a linearly sequential manner, then only we can apply this waterfall model. So this is the process model diagram. So it includes 5 important framework activities. The first one is the communication phase. So in this communication phase, we are doing the project initiation, and then we are gathering the requirements in this communication phase. So the business development team members and all the stakeholders will be sitting together, and they will be gathering the requirements from the client. And then after gathering the requirements, we will be prioritizing the requirements, and then we have to move on to the planning phase. In this planning phase, we will be estimating the cost, budget, and the schedule, and we have to keep track of that schedule. And in, at the end of this planning phase, we will be coming out with the software requirement specification document. And then we'll using that document, it is going to be an agreement, and we'll be doing the modeling phase. So it is called, SRS is called as an agreement because, so the development team members, they cannot develop the requirements in under manner, as well as they have to develop all the requirements they have been specified by the client, and the customer also cannot demand for more requirements after they sign to this SRS document. And then we will be moving on to the construction phase. In this construction, we will be doing the implementation, we will be doing the coding. After writing the coding, we will be doing the testing as well as debugging in order to verify and validate the system. And finally, we will be delivering the product to the client in the deployment stage. So after delivering the product, the customer may be getting some changes. They need some maintenance. Based upon the feedback, they can get the support from the business development team members. So at the end of this deployment stage, the software can be delivered to the client. So this is the conventional engineering cycle, so which includes the requirements definition. So in this requirements definition, we will be gathering the requirements from the client, and we will be prioritizing the requirements. So based upon the requirement, we will be designing the software. Okay, after designing the software, we will be implementing the requirements, and we will be doing the unit testing. So unit testing is nothing but the modular testing. So each and every module will be tested, and finally we will be integrating all the modules in order to come out with the final system. So after integrating the modules also, we will be doing the system testing. So once the system testing is over, so the software will be installed in the client's environment, and then we will be doing the maintenance if the customer is needing any changes. So this is the process model diagram for the linear sequential model. So it includes analysis, design, coding, testing, and debugging, that is maintenance, as well as documentation. So this analysis and design is going to be including in the system and the information engineering process. So in analysis, we'll be gathering the requirements and we'll be planning the budget and schedule. So once once the feasibility study is carried out, and if it is possible to implement the project, then we'll be moving on to the design phase. So in the design phase, we'll be doing the modular design, as well as we'll be doing all the diagrammatic form like ER diagram, data flow diagram and state transition diagrams, and based upon the diagram we'll be implementing the coding. So after writing the coding, we'll be doing testing as well as debugging, and then we'll be deploying the product to the client, and based upon the feedback again the cycle is moving on. So since it is all the process are carried out in a cycle, this process model is also called as a life cycle model. So this is a variation of a waterfall model, what is called as a V model. We will be doing the verification and the validation in this model. So in this V model, in the left hand side we can see all the process carried out in the life cycle model. In the right hand side we will be seeing the software quality assurance activities carried out. In requirements modeling, we will be doing the acceptance testing. In architectural design, we will be doing the system testing. In component level design, we will be doing the integration testing. And in the code generation phase, we will be doing the unit testing. So in the left hand side, we have shown the activities. In the right hand side, we have shown the software quality assurance activities carried out in the process model. This model we call the B model. So next we are going to see the limitations of waterfall model. So till now we have seen what is waterfall model, what are the activities carried out in the waterfall model, and now we will be discussing what are all the drawbacks that are present in the waterfall model. So even though it is following the linear sequential process, we are having a lot of limitations in this linear sequential model. First one is all the requirements has to be explicitly mentioned in the initial stage itself, which is very difficult. So the nature of requirements may change during the software development process. So one should attempt to give complete a given stage. Only then they can move on to the next stage in the software development process. The customer cannot wait until the entire development process is completed. So one cannot accept that once the product development is finished, everything is finished except maintenance. So surprises will be very much high at the end of the software development process, because there is no involvement of the customers in between in the software development process. So some teams sit idle for other teams to complete the software development process. So if these are tolerable, only then we can go for the software linear sequential model. The problems that are present in the waterfall model is that the real projects rarely following this process model, because it has to follow each and every activity in a linear manner. So it is very difficult for the customer to mention all the requirements at the initial stage itself. So the customer must have enough patience to sit idle till the process has been completed and they come out with the quality product. Only when the project development is completed, only then they will be getting the software product. So next is the incremental process model. So till now we have seen about the waterfall model, that is a conventional process model. So since we have various limitations in the linear sequential model, in order to overcome that, we are going for incremental process models. So in incremental process model, the first process model is the incremental model. So it is followed only when all the initial requirements are well understood and well defined. It combines the elements of linear model as well as the parallel process model. So in the previous model, only linear sequential process is carried out, but here we are going to combine both linear process as well as the parallel processing. So each linear sequence going to produce the deliverable, which we call as an increment. The first increment is going to be the core product, which includes the basic requirements as well as many supplementary features, that is known and unknown will be features will be remain undelivered, which can be carried out to the next increment. So the next increment can be planned by doing the modifications in the first increment, as well as additional features of the first increment can be added for the next increment. So here we can see the x-axis shows the time and the y-axis shows the functionality carried out. So it has the 5 key process framework activities, that is communication, planning, modeling, construction and deployment. So once the first process is over, it will come out with the first increment, and then if there is any changes, if the customer is giving any feedback, so based upon the changes, they can start up at the end of the construction process in the first increment, they can move on to the next increment. So here, once one increment is started, so it will be completed. It is following the linear process. So if there is any changes, then it can be carried out in the next increments. So this hence this model is called the incremental process model. So the advantages of the incremental model is that it is followed when enough staffing is not available. Okay, so increment can be planned to manage the technical risk. So at the end of one increment, they are coming out with a prototype, so which can be provided to the customer, and the feedback can be asked from the customer. So if there is any changes, then it can be moved on to the next increment. So it focuses more on the delivery of operational product. So with each increment, so all the user requirements can be listed out, and it can be prioritized based upon the high priority user requirements. It can be included for the early increments, and later it can be added to the next increment. So once the development of the increment is started, the requirements are frozen, though there is new requirements are going to be evolved. So once new requirements are coming, it will be carried out to the next increment. So the customer can be highly involved in this incremental process model. They can give the feedback at the end of each and every increment, so that they can come out with the next increments. So early increment is going to be acting as a prototype, and it lowers the risk of overall project failure when compared with the waterfall model. So next process model. So here we are following various increments. The time taken to implement these increments will be very much high. So in order to overcome that, we are moving to the next incremental process model, what is called as the rapid application development model. So this is shortly called as a RAD model. So this RAD model is going to be the incremental software development process. From the name we can see it is a rapid application. So it is going to follow extremely short development cycle. So in order to develop the application in a rapid manner, in a faster manner. So how to develop the product in a faster manner, in a rapid manner is, it is going to make heavy use of off-the-shelf components, what we call as the software components. Okay, so it is this RAD model can be called as a high-speed addition of the linear sequential model. So the requirements must be well understood here, and the project scope must be constrained in the initial stage itself, like a waterfall model or incremental process model. So rapid application development process, it enables the development team to implement a fully functional system within 30 to 60 to 90 days of software development process. So within 3 months we can come out with a fully functional system. So this is the process model diagram. So it includes communication and planning. So many team, they will be involved in this gathering the requirements as well as doing the planning process, and this construction, modeling and construction will be done in a parallel processing manner. So we are going to divide the complete project into various modules. Each and every module is going to be implemented by every team. So team 1 is going to do modeling and construction. Team 2, they are going to do the modeling and construction. Similarly, n number of teams will be doing the modeling and construction in a parallel processing manner. And finally, they will be integrating all the modules in order to come out with the final product. So here integration testing will be done, and it will be deployed, the product will be deployed to the customer. Based upon the customer feedback, again the changes will be done, and the final product can be evolved with a high quality, and it will be delivered the product to the client. So when seeing this rapid application development, we can have various advantages when compared with the previous models. So a fully functional system can be developed within a very short development cycle. So once application is modularized, each major function can be implemented within a very short duration of time, less than 3 months. We can deliver the complete product, and we can deploy the product to the client. So each major function can be addressed by the separate team and then integrated to form the entire system. So even there are various advantages of RAD model. We are having a lot of drawbacks in this. So it cannot be applicable for large projects. So it requires enough human resources to be available. So the project will fail if the developer and customer are not completely committed. So it become problematic if the system cannot be modularized into various modules. It is not appropriate when technical risks are very much high. So in order to overcome these disadvantages in the RAD model, we are having evolutionary software process models. So evolutionary process models, it is going to evolve over a period of time. All the complex software process will be evolved over a period of time. So requirements may often change during the development process. So tight market deadlines will create a lot of difficulties in order to complete a product within a particular short duration of time. So a set of core product requirements will be first well understood. So those requirements has to be implemented at the initial stage, later on following with the later increments when detailed extensions are coming out during the development process. So we need a process. Software engineers need a process model that is accommodate a product within over a period of time. So evolutionary process models are going to be iterative. These process models, it enables software engineers to develop the increasingly more complete versions of software over a period of time. Okay. So there are three types of evolutionary process model. The first one is the prototyping model, second one is the spiral model and win-win spiral model, and third one is the concurrent development model. So the first one we can discuss about the prototyping model. So prototyping model, it starts with the communication phase. It is going to include the requirements gathering in the communication phase. So all the requirements will be gathered in the communication phase. We will be prioritizing the requirements and we will be analyzing all the requirements, and then we will be moving on to the design phase. So here we will be applying quick plan, and a quick design is carried out in the prototyping process. So quick design is going to lead to the prototype construction. This prototype is going to be the initial operable model. So this initial operable model will be giving to the customer. Based upon the customer feedback, the new changes can be incorporated in the software development process in order to come out with the final product. So the prototype is deployed and it is evaluated by the customer or end user. So based upon the feedback from the customer or end user, the changes will be incorporated in the later increments and will be coming out with the final satisfiable product to the customer. So this is the process model of the prototyping process model. So it includes communication, quick plan, quick design, prototype construction, and delivery and feedback. So in the communication, we are going to gather all the requirements, and then we will be doing the quick plan and the quick design. So it leads to the prototype construction. So once the prototype is constructed, it will be provided to the customer, it will be deployed to the customer, and then we will be getting the feedback. Based upon the feedback, new versions of the software development will be obtained. So the problems that are present in the prototyping model is that the customer will cry foul and demand with the initial prototype, make a few changes in the initial prototype and come out with the final product. So when the customer wants in such a way, the quality of the software will be completely reduced. So that affects the software quality enormously. So the developer often makes implementation in order to get a prototype working very quickly. So developer often makes implementation in a quicker manner, so which reduces the quality of the software product. So in order to overcome these problems that are present in the prototyping model, we are going to the next model called as the spiral model. So this spiral model was first proposed by Barry Boehm. So this is an evolutionary process model which includes the iterative nature of the prototyping model as well as the linear sequential model. So it provides the potential of a rapid application development over a period of time. The incremental versions of software can be developed in each and every spiral of that process model. So using the spiral model, the software is developed in a series of incremental process, and the incremental releases can be obtained. So during early iteration, the incremental releases might be paper-based model, or it can be a prototype. So once a prototype is obtained, it will be delivered to the client and will be getting the feedback from the customer. So we'll be involving the customer in between the software development process in order to come out with a quality product. So during the later iterations, increasingly more complete versions of software system can be produced. The spiral model can be divided into a number of task regions, number of framework activities called as a task region. So typically there will be around 3 to 6 task regions will be present in the spiral model. So we can see the spiral model diagram. So it includes around 6 task regions. So the first task region is going to include the customer communication. So here in the customer communication, we are going to gather the requirements and then we'll be moving on to the planning phase. In the planning phase, we are going to plan the budget, we are going to plan the resources, we are going to plan the schedule, and we are going to come out with the SRS, and then after getting this SRS, we are going to perform risk analysis. So in software development, we will be getting lot of software risk like technical risk, business risk, people risk, organizational risk. So in order to analyze all the risk, this spiral model is paving a way. Okay. Then we will be moving on to the implementation phase. So we will be doing the coding, construction, and testing, debugging will be done in the engineering process, and then we will be doing the construction and release in the construction and the release phase, and then we will be deploying the product to the client in order to get the customer evaluation and the feedback. So based upon the feedback of the customers, we are going to come out with the later increments. So here we are seeing 4 boxes. Okay, the first one, the first task region, first spiral is going to come out with the concept development projects. It is mainly used for concept development projects. So next, if we move on to the next spiral, so it will be mainly applied for new product development. And then for product enhancement projects, we will be moving on to the next spiral, and finally for project maintenance maintenance projects, we will be moving on to the 4th spiral. Okay, so based upon each and every spiral, we will be moving on to the newer type of projects. So this spiral model, it is going to divide into various task regions, as well as it helps to perform risk analysis, which is not applicable in various other process models what we have discussed. So the advantages of this spiral model is that it is a realistic approach to the development of large scale systems. So this spiral model can be applied for large projects, okay, so which can be involved for around 60 to 90 or around 6 months or 1 year projects. So a software evolves when project progress, the developer and the customer better understand because they are having involvement in between the development process. So we are going to we are performing risk analysis. So since we are doing risk analysis, all the risk can be eradicated and we can come out with a quality product. So the users prototyping, it uses a prototyping as a risk reduction mechanism in the spiral model. So it enables the developers to apply the prototyping approach at the initial stage, and based upon the customer feedback, the new increments can be come out in the later stages. So it maintains a systematic stepwise approach suggested by the classical life cycle model, as well as it involves an iterative process. So the spiral model demands a direct consideration of technical risk at the initial stage itself, and later on we can remove all the technical risk. So once we are removing all the technical risk, we can come out with a quality product automatically. So if properly applied, this reduces the risk before they become problematic at the later stage. So it maintains a systematic stepwise approach at each and every stage. It reduces all the risk. It reduces all the problems that are created in the initial stage itself. So here also we have limitations. So the limitations include, it may be very difficult to convince the customers at the initial stage. So it demands considerable risk assessment expertise needed, because only based upon their expertise the process will become successful. So if a major risk is not uncovered at the initial stage, it will create enormous devastating effect in the later stage. So finally, the model has not been used widely because as compared with the linear model or other models, this spiral model is not much used. So in order to overcome all these limitations, we are moving on to the next process model, what is called as a win-win spiral model. So this win-win spiral model, it includes win-win conditions of the customer as well as the developer. So the customer wins by getting the system or product that satisfies the majority of the customer needs. So the customer wants the product to be completely satisfactory. So only when the customer gets a quality product, then the customer wins. The developer will win if all the requirements has been implemented in the software process in order to come out with a achievable product, and within the deadlines he has to develop the product. Once he develops the project within the budget and schedule, then the developer wins. So these are the two win-win conditions in the win-win spiral model. So the following activities are carried out in this win-win spiral model. The first one is identification of the system or subsystem by the stakeholders, then determination of the stakeholder win conditions, and third one is we need to negotiate the stakeholder win conditions. So first of all, we have to identify all the stakeholders. So stakeholders are nothing but the persons that are directly and indirectly involved in the software development process. The main stakeholder is the customer, and other stakeholders involve the business development team members. So we need to identify all the stakeholders, and then we need to determine their win-win conditions. So once the conditions has been come out, we have to negotiate the conditions, and based upon the negotiation, we have to start up the development process. So this is the process model diagram of the win-win spiral model. So here the process model diagram will be similar to that of the spiral model. So it includes various task regions. So here we have 7 key process activities carried out. The first one is we need to identify the next level stakeholders. We have to identify all the stakeholders, and next we have to identify the stakeholders win conditions, and then we have to negotiate their win conditions. We have to reconcile in the sense negotiate, as well as we need to reconsider their win conditions. We have to establish their objectives. Once we establish their win conditions, then we have to come out with the process and analyzing the risk and resolve the risk. So once the risks are carried out, we have to come out with the development process. So once the development process is completed, we have to verify and validate the product, and then we have to deploy the product to the client in order to get the reviews as well as the comments from the client. So based upon their feedback, the final product will be completed, and it will be provided to the customer. So final model in the evolutionary process model is the concurrent development model. So concurrent development model is mainly used because in order to come out with the software development in a faster rate. So it presents schematically a series of major technical activities, tasks carried out. So the analysis activity is done in the initial stage in the none state, and then it will be moved to the under development state. So once the analysis is started, it moves from the under development state to the awaiting state if any changes has been pointed out by the customer. So this is the process model diagram of the concurrent development model. So it will be in the none state in the initial stage. So once it moves from none state to under development state, then the analysis activity has been started. So once the analysis activity is started, it moves from the under development state to the awaiting changes state. So it will move to the under revision if there is any changes has to be carried out, and then it will be moved on to the review process. So once the review is completed, it will be baseline, and finally the product will be implemented and it will be deployed to the customer. So each and every box here, it represents the software engineering activity carried out in this concurrent development model. So as a summary, So we have discussed the perspective process model. We have classified the process models. So here we have perspective process model. We have iterative process model. We have evolutionary process model. So apart from this, we have specialist process model and agile process model. So these process models are mainly used in order to develop a software product in a systematic manner. So this software process model, it can be compared with the house plan. In a real-time scenario, it can be compared with a house plan. So how a plan is needed for constructing a house, similarly for developing a software, we need this software process models. So when we follow these process models, we can come out with a quality product, which is the main objective of the software engineering process. Thank you.